In this video, we'll look at calculating p-values using the graphing calculator. So, starting off, we're going to look at example 9.9, where we have a hypothesis test for the mean. You can see from the picture that the p-value is the area of the tail in the sampling distribution, marked off by the sample mean. It's a normal distribution, and the mean is the population mean that you hypothesize in the null hypothesis. The standard deviation is the population standard deviation divided by the square root of the sample size. So to find the area in the tail, we use the normal CDF command and just find the area in that tail. It's going from 17 all the way to the right, and then the mean would be 15, and the standard deviation would be 0.5 divided by square root of 10. And that will give us the probability of falling in that tail. Now, if you have a two-tailed test, you would need to double that number. Suppose we had a sample mean of 14 and we were doing a left-tailed test. Then simply go all the way to the left and stop at 14 and use the same mean and standard deviation. And there's the p-value for a left test, where the sample mean was 14. Now, if we were to work with proportions, we still have a normal distribution for the sampling distribution. And we will look at this example here. In this case, the number that shows up in the hypotheses is the hypothesized population proportion, but that will actually still play the role of the mean in our sampling distribution. So the 0.5 here for the mean. The standard deviation is the square root of p(q) over n. Remember, that's the adjusted standard deviation using the central limit theorem. And in this case, we have a sample mean of 0.53. So you can tell it's a two-tailed test, and what we're going to do is still use the normal distribution, and we're just going to find the area in one tail and then double it. So we want to go from 0.53 all the way to the right, and the mean is the 0.5 from the hypotheses, and the standard deviation is the square root of 0.5 times 1 minus 0.5, it's your p and your q, divided by n, which is 100. And that plays the role of the standard deviation for the sampling distribution of proportions. And then we would need to double that to get the actual p-value, and then you can see that matches up with the p-value they calculated there. So this shows how to calculate p-values in both the mean and proportion cases, and for left-tailed, right-tailed, and two-tailed scenarios. As far as getting pictures, you can hand draw your picture so that you get something like this, or use one of the websites for having those automatically generated. Yeah, it's up to you.